Hey, it's me again. I saw the other 12 speakers a bit worried about the two solid talks we had, so I thought I'd ground everyone, set a base so that everyone else is not worried after me. Talk about the boring stuff in C++23. So yeah, I'm going to be talking about deducing this and stood forward like. Both of them were introduced in C++23. Bit about me. I'm Sarthak. I'm a tech lead at a high-frequency options market-making firm in Chicago. You can read the rest in the slide. So yeah, let's get right into it. Imagine you're writing a class which has a container. Just for an example, I have this chessboard class. It has an 8x8 chessboard, and it's a linear array. And being the good developer you are, I know there are some eyebrows being raised probably right now that the board container should be private. It will be. I just missed it in this slide. But yeah, being the good developer you are, you've provided an abstraction to the client and an at method, which returns a reference to the client passes your row and column, and it returns a reference to the element. That's great. Except when the client now writes a print board method, just needs to print the board, and there's no reason that it should be a non-const reference. So the client writes a very good function, takes in a const reference, and now this fails because the add method is non-const. So you decide to add a const overload. That's great. Accesses the board in a const manner, returns a const reference. That's great. But now there's some oddity here. You can see that you're now starting to repeat stuff. You're calling the exact same function board.add in two different methods, and this could be way more complicated. So it doesn't look that great. And this is exactly what deducing this addresses. But before deducing this, what you could do is you could have a static auto ref add function. What this would do is that the first parameter would be an auto reference. The second all the rest of the parameters would be the same. And each of your add function, the const and the non-const overload, would simply pass the object type. And with the auto type deduction rules, it would either be deduced to a const ref or a non-const ref, depending upon what the caller object is. So you could not repeat yourself even before C++23. But deducing this makes it much simpler. Oops, okay. So if you ignore the second half of the slide, the first half is basically what deducing this is. It simplifies the implementation of the static add method that I had previously. With deducing this, now you can have a return type as an auto ref. The first parameter always has to be this auto ref, like the templated ref, with the this keyword, which signifies deducing this. And then there's going to be rest of the parameters. So now, if the client calls this with a const object, then it's going to return a const ref. If the client calls it with a non-const object, it's going to return a non-const ref. That's great. Except if the client now tries to do std move chessboard.add 00, it returns an error. But that's pretty simple to fix. In this slide, I just have, instead of the two overloads that I had in the previous slides, an L-value non-const overload, an L-value const overload. I have overloads for the R values as well. So basically, instead of, in most of the classes like std optional, instead of repeating just twice, it's actually repeating the same code 4 times before C++23. And now, with deducing this is all you need to do. You can have a forwarding reference of the return type as an auto anan, which is a forwarding reference. The first parameter would be this auto anan for forwarding reference, and again, this keyword signifies the deducing this usage, and that's all. You're done. No need for the 4 overrides. There is one drawback in this slide, though, which is the usage of stood forward, which stood forward like addresses. But I think I'm out of time. And that's always the case with lightning talks, so I'm going to skip that. All right. I think I can do it in 30 seconds. So if you use the function as at the very bottom, stood move chessboard.add00, with the current deducing this implementation, it forwards the object type and then calls the .board.add method with the forwarded object type. So if you have a R-value reference of the object, it's going to call it's going to forward it as an R-value reference and then call the .add method. But what you want to do is that the return type should be the same as the object passed, which is the R-value reference. And forward like is meant for those purposes. But I think it's probably not doing justice to it in 30 seconds. So I'll send the slides. Feel free to play around with it on Godbolt. And that's all. Thank you.